So 8.2 is inverse and joint variation. If you have a good understanding of the direct variation from 8.1, then this stuff is pretty straightforward. Okay, so inverse and joint are just other ways that these things can vary. So this is the terminology you're going to see in the problems, and it's going to create this equation. So y varies inversely as x means y equals k over x, where k is still the constant of variation. Joint variation, we're going to add a third variable. Okay, so now we're going to use x, y, and z, right? And it's basically just stacking double, it's basically doing two direct variations, okay? So z varies jointly as x and y means z equals k x y. So, simple problems first, right? If y varies inversely as q, so that means that y equals k over q. Always write that equation, okay? You want to write that equation every time because otherwise you could easily mess it up if you try to do it in your head. Okay, you solve these in the exact same way that we did the other way. I think it's easiest to probably use a proportion, right? Unless you have to find the k, right? So to get k by itself, we have to multiply both sides by q. So we've got y1 q1 equals y2 q2. Okay, so y1 is 22, q1 is 6, q2, and y2. 6 times 22 equals 15q. Okay, so we've got, oh, there should be a 22 there. Yeah, there should be two 2's there. All right, so 22 times 6 divided by 15 is 8.8, and that's the answer for q. All right, number 2, we can actually do a joint variation and an inverse variation at the same time. All right, so r varies jointly as s and t, tells us we've got r equals kst, but r also varies inversely as u. Right? You don't have to create a new constant, you don't have to have a second k in there, so you could just still use the same k and just divide by u. So something that ever looks like this, y r varies jointly as s and t and inversely as u, you could just stack all together to r equals kst over u. Okay, now to get k by itself for this time, we had to multiply by u and divide by st. So we've got r1 u1 over s1 t1 equals r2 u2 over s2 t2. Okay, and you can plug all these in and solve because we have r1 s1 t1 u1 s2 r2 t2 u2. Okay, you plug all these in and we have 18 times 4 over 2 times 3 equals 6 times 4 over 2s. Okay, now to solve this, I'm just going to cancel a whole bunch of stuff out, do as much in my brain as I can, so this can cancel out with this and make it 6, that can cancel out and make it a 2, so we've got a 12, that cancels out and becomes a 2, so 12 equals 12 over s, which means that s has to equal 1. Let's go to the... So, we have the time required to travel a given distance, that's going to be one variable, time, is inversely proportional to the speed of travel. Second variable, s. So t equals k over s. Okay, let's solve for k. So we have t1 over s1 equal... that's just totally made up. That's very wrong. We have to multiply the s. Okay, so t1 s1 equals t2 s2. We've got a t1, 3.6 hours. S1 is the speed during that time. T2, how long will it take? That's what we're looking for. And we have the S2 is 90. So we have got to check your units, just make sure we're all good. They all are all the same, so that's important. So we have 3.6 times 70 equals 90 t. Multiply it out, 3.6 times 70 divided by 90, and we get 2.8. T equals 2.8 hours. And number 4, Okay, we're going to do the joint variation and the inverse variation stacked on top of each other again, but this time we're going to manipulate our variables. Okay, so once again, just like we did with direct variation, you can manipulate the variables and do stuff with them. So we've got the square of v, not just v by itself. So we have r varies jointly as s and t, and inversely as the square of v, so v squared. Okay, so what that means is we need to multiply by v squared, divide by st, so that way we can solve for k. So we have r1 v1 squared over s1 t1 equals r2 v2 squared over s2 t2. Plug in everything we've got. We've got 1, 1, 1, 1, 2, 2, 2, 2. Okay, and we can plug all those in. So R1 is 3.78. V1 is 5, so V1 squared is 25. And S1 is 18. T1 is 3. R2 is what we're looking for. V2 is 4, so 4 squared is 16 over 12 times 4. Okay, so you can work with this. You can do this obviously all on your calculator. Anything you can cancel out, I usually do. So I'm going to cancel this 4 out and make it a 4 on top. And then cancel that 4 out and make it a 3 on bottom. Just makes it nice and easy for us. Okay, on the left side, you can actually work this out. 3.78 times 25 divided by 18 divided by 3. And you get 1.75. So 1.75 equals r over 3. So multiplied by 3, and r equals 5.25. Now the last problem here, we have the surface area. So for this one, because we have more complicated numbers, it might be a good idea for you to not solve for this and create the proportion and actually find k. Alright, so I'll show you how to do that. So the surface area of a cylinder varies jointly as the radius and the sum of the radius and the height. So the surface area, S, varies jointly as the radius, R, and the sum of both the radius and the height. Well, the radius and the height is R plus H. So notice that R is going to appear twice in here. So we had to create our equation. So we have S equals K R plus H. Okay, it varies jointly as both R and R plus H. So I think that it's probably best for us to use this second sentence to solve for K, and then use that K to solve our problem. Okay, so we've got a cylinder that has a height of 8 and a radius of 4 and a surface area of 96 pi. So 96 pi equals K times 4 plus 8 is 12. Okay, so you could just divide the 48 over and get the K equals 2 pi. Okay, so now we have a new equation. S equals 2 pi R plus H. And our situation tells us that we have a radius of 3 and a height of 10, and we want to find the surface area. So S equals 2 pi times 3 times 10 plus 3 is 13. So we have, let's see, we've got 39 times 2 is 78. So S equals 78 pi. And that's all for the variations.